Right, let's look at another word. So be careful. Independent events. You get the complement, you get the mutually exclusive, you get the independent. The independent events, I'm just going to say, have no effect on each other, and then I'm going to explain what I mean by that. Independent events, I mean, if I do one experiment and thereafter I do another experiment, the second one, its outcome should not depend on what happened with the first one. So, for example, toss a die, then flip a coin. What you get from flipping a coin has no effect or no result from tossing a die. Whatever I get on the die is not going to tell me what's going to happen when I flip a coin. Even if I set my two events of flip 2 coins. If I flip a coin, I can get head or tails. If I flip the second coin, I can still get head or tails. So the second action is not dependent on the first action. Now, please notice the difference between mutually exclusive and independent. With independent, we're talking about doing one thing and then doing another thing. Mutually exclusive is where I'm saying, if I do one thing, can I get an answer that comes from both the others? So mutually exclusive would not be, let's say, A and D are not mutually exclusive. Because I could get, remember D was get an even number. But there are even numbers in A. 2 is an even number. So if I got a 2, it did come from both A and D. But it was still just when I did one action, could I get a result coming from 2 of my events that I have decided on. Whereas independent events are, if I do something and then I do another thing, the next one doesn't depend on what happened the first one. So when would it not be independent? Let's think. If I have, let's say, a bag with colored discs in it. We will use this example again later. So for instance, there are 3 blue, 2 green, 5 red discs in there. Now, if I draw a disc, I look at its color and I don't return it to the bag. Then I draw another disc. Okay, let's just see this again. Imagine you've got this bag and there are all these discs. You can't see inside the bag. You put your hand in, you draw a disc. You note its color. It's either blue or green or red. But you don't put that disc back into the bag. What happens now with your second draw? You've only got 9 discs left to choose from. So your sample space only consists of 9. So here your sample space had 10. Here, your sample space now only have 9. So the denominator is going to change. And then furthermore, if for instance your first one was a blue, then in the second case there are only 2 blues left. So your probability of getting a blue again is going to be different. It's influenced by what happened with your first draw. So those are independent events. Right, this lesson, very important. Make very sure you understand what we mean with these words.